Hello, everyone. So since going to be late soon, so let's talk about some serious stuff a bit. And today I would like to talk about security, especially security in web. And I think this topic will be rising next coming years because, and let me actually explain why on one example. Around a year ago, one security researchers group found vulnerabilities in around 60 companies, as I said. Actually, they found vulnerability in one library. It's Swagger UI. You probably used it a lot to display API documentation. And using vulnerability in Swagger UI, they were able to take over accounts in different companies like PayPal, Microsoft. And a few interesting facts about this research. First one, that Swagger UI actually had a protection in place. So the developer of the library, they thought about threats, and they put a filter in the place where vulnerability was found. But security researchers still were able to exploit it, still found a minor issue that made them able to steal the data in different companies. And another interesting topic is, of course, if you go to Swagger on GitHub and find the file with vulnerability and put it into ChatGPT, ChatGPT happily says you 5 places where you can potentially have different issues in that file, which means that in the coming years, probably malicious actors, hackers, they will be able to attack more, to crack sites more with higher speed, to craft more sophisticated attacks, more targeted attacks. That's why I think that we also need coming years to do a little bit more in this field. A slide about me. My name is Eugene, and I do different stuff at work. And sometimes I work on security-related things like contributor, or maybe I'm trying to convince people to invest into security, to put some effort into security. And from my experience, my feeling that the field of security right now could be better. And there are some issues that we have right now. For instance, it's hard to say how much to invest. You can harden and harden software, and you never know when to stop. Or maybe you can even do not look into security, and it's kind of ad hoc process, right? It works on intuition. If we thought that we need something to protect from, we put somewhere. But is it really a threat for us? Is it really something that is important to protect? Is it effort worth the shot? Right now, it's hard to answer, usually. Many security recommendations that are given in books, they can be generic. So when you try to apply in your specific context, it might not be fully applicable to your project, to your environment, because you have many legacy or maybe some other stuff. And for instance, in PM audit, right? I don't know how many of you try to keep it green, but if you were able to do it on a long time, you are probably heroes, because most of us tries to keep NPM audit complaining on the same level. We also have to learn a lot. We have to learn new languages, new frameworks. Right now we need to learn how to talk to AI. And most likely that learning is not focused on security. Probably there are some points, but in this learning rush, you rarely focus on security because it's a separate field. There are a lot of stuff you need to know to keep software secure. Some of the advices that we follow, they are actually good one, like using open source libraries. If you need to implement something, especially related to security, the best thing you can do is to take a well-known open source library to put into your project. But what you need to understand that it's still responsibility on you, because you put this library on your project, and the library, even is a good one, it's protected one. Many nice people worked on the security features in it. It still might have 0 days vulnerability. So at some point of time, your software that is running in production might be vulnerable, even if you use open source libraries that are good in it. Or like static analysis that complains a lot, creates a lot of warnings that you never pay attention into. The same, like we are thinking that it might backup us in the same time. We tend to not to look into it because of a lot of noise generated by static analysis. So, is it hopeless? I think that if we put a little bit more attention into it, a little bit more focus, then probably we'll be doing a better job. And the thing is that you should start from doing some conscious effort for security. Try to embed into your daily work. Try to apply it into your processes, into your development flow. I will talk a bit later of how can it be done. When you talk about security, it's a scary thing, it's a risky thing, but you should be conscious about impact on your specific project. Maybe you're selling photos of cats and cats are not famous enough right now. So if someone steals those photos, it will not create a big impact on you. But if cats are getting more famous, then probably stakes are more higher and you need to invest more. So what you can do, you can try to understand the impact on your product if someone can hack you from potential threats. You should look in a different risk management about cost of protection, about potential harm, losses, what can happen to your application. Another thing is that if you decide to create a protection, to build something, to harden something, to build something more safe, then try to think from a different angles. Because again, even if you use open source software, it might have vulnerabilities in times that are not closed. So you might be vulnerable during some period of time, and it's a good idea to build a protection from different angles, like putting web application firewall on top of your application. Maybe some other things that I also will be talking later a little bit. One of the processes that can help to build your security on day-to-day basis is a threat modeling. It's kind of a systematic approach, like Scrum or something that we are following. The threat modeling tries to do the same. And this first time I heard about threat modeling, I thought that it's one of those advices that are really hard to follow, because threat modeling is driven by security people. And I think it has some marketing issues. Like this is a scheme, it's enterprise-grade matrix with different attacks. And many threat modeling guidelines say that you should know this in advance. And this only titles. So clicking on each, you will see more content, how to exploit. And guidelines say that you should know this in advance. And of course, it's good if you know this in advance, but it's not always possible. For me, it was not possible when I tried to learn how to do threat modeling. What you can start from is from these 3 steps. They're really simple, because it says design the system, but it shouldn't be really design. It should be visual representation, which you can use to threat modeling. Try to put a minimal functionality that you may be working right now, like a feature or a flow, to put into visual form when you can learn to see how data flows, to see what inputs and outputs. It should stimulate the brainstorming session. When you have this visual representation, try to identify possible threats, and it's like drawing a novel, right? But what is worse here is to invite as more people as possible and as diverse position as you have to this session. You can do it alone, but it works better in a group. So if you invite a group of people that is staring on some design, on some feature data flow, they likely find more threats that you will do if you do it alone. When you did it, when you try to find possible threats, and you do not need to find any possible threat in your application. Try to focus on what are important for this, for your specific flow. When you have list of the streets, then try to describe how are you going to defend from them, what protection measures are you going to build. And again, street modeling says more about the process you should apply. Like there are more steps, but you can apply those steps later when you get comfortable with basic steps, when you start to explore more in security, learning new things. You can inject more techniques. So brainstorming sessions will be more effective, and you will find more threats and give more quality results. Here's some engineering system I created, like a picture that kind of similar to usual e-commerce system. And it focuses only on two use cases. It's adding to cart. It's like a site where you can put goods on a cart and then buy something, and applying a promo code. So a promo code, again, if you want to buy something for less and you have some kind of promotion from a site, you can put some promo code and pay less. In this picture, focuses only on two flows, and on the right from the internet, you can see microservices. So the team that did it probably heard about it, and different databases, back office with uploading prices, etc. And that is your input for street modeling. Based on this, you can see different flows, how inputs are given, different actors that you have administrators, you have users, and this is input for our brainstorming. Now, here's an example of potential threats that I just added. For example, there are possible more. Again, in a different context, there will be different threats that you will be applying. For instance, here we can see that we use DynamoDB, and DynamoDB is a good database. But what we know about DynamoDB is that it's eventually consistent by default. And if it's eventually consistent by default, you probably, and you haven't configured consistent rights, that probably you might have vulnerabilities that allow to use promo codes multiple times, the same promo code, if you have a limitation for them in your system. Or you can, attacker can try to confuse prices in the card. So if you have something that costs 100 euros, hacker can try to buy it for 1 cent, for instance, and you will start losing money. And what is important in this picture is that all of these potential threats that you see, they are specific to this system. So we are not focusing on these three guys that usually pop up when we are talking about security. These ones are related to a business logic. You can invite to street modeling business people who can give you a different angle on the business flow and what is important for them and what is not. And yes, we all remember about these threats, and we, for the past years, we probably built a lot of measures to protect from this. We have standard advices how to overcome it. Of course, when requirements are growing, we might not fit the default advices, but anyway, we need to fill into requirements. And when default advices doesn't work, then things are going to be a bit risky. Let's talk about XSS protection, for instance. React.js, they have property called dangerously set something, and this property explicitly says that it is risky one. You have standard advice that you should encode content on render, but if you need to actually render rich text, then probably everything goes to sanitation content, right? And sanitization is a process when you remove what is dangerous for your application for user input. But sanitization, in our minds, is like take a library, put it into the code, and you have a secure input or secure output. But sanitization is not that obvious as we might think about it. This is a book, very interesting. I suggest to read it. It's from security researchers called Sam Curry. And they work on a different interesting stuff. They were able to hack a lot of car manufacturers. So they actually exploited Ferrari. And in this article, they described how they did hack Apple for 3 months. What is interesting is this set of symbols. They were able to put into iCloud Mail and actually take over iCloud account. And it's Apple. They had a lot of protection, probably. But security researchers still were able to hack them, to take over accounts, and it's really interesting to read how did they get to this sequence of symbols. They played on complexity of parsers for HTML and CSS languages. They tried a lot of standard payloads, but they didn't work, so they built a custom payload for Apple. Another example that in the beginning I was talking about vulnerability in Swagger UI. Actually, it was not Swagger UI, it was DOM Purify. It's standard de facto for sanitization in JavaScript world. And this is default library that you take when you need to do sanitization in your application. And it still had some vulnerabilities in the past which were successfully executed by the researchers. Still, if you need to work with rich content, with dangerous input, you should take these libraries because DOM Purify is a very good one. And vulnerabilities, they will happen, they will still happen, and you should not throw it away only because it was vulnerable somewhere back in time. Another example, this page shows amount of known ways to escape XSS protection. When I tried to scroll it really fast, it took 25 seconds as far as I remember. You can open this page by yourself and look at the amount of sequences the community built to escape XSS filter and different XSS protections. So, how can we deal with it? And the idea that right now browsers are very rich in terms of functionality. So we can utilize browser features to build additional layer of security. So you should not throw up all the sanitization and other protection measures on the code level, but rather to think how can you build a backup when something is wrong with software that you use, with dependencies that you use. First example is a content security policy header. It's been a while for this to exist in the browser. It's not actually only header, it's also a meta tag. Meta tag is a bit more less powerful than a HTTP header. And content security policy header allows you to build a list of resources you use on your site. So you actually explicitly specify what domains is allowed to your page to load different stuff. Like in this example, you are allowed to load any image on the page from any domain, from any protocol like HTTP, data, blob, doesn't matter. It allows to load videos only from Fest.dev website and youtube.com, and scripts can be loaded only from cdn.fest.dev. Everything else is forbidden. Let me show a quick example how it impacts the site. So here it is simple site. Like it's a React application. I took a default framework and it prints just a text. And of course, I printed this text without any protection. So if we put standard XSS payload here, we should be able to see this, not because the cache probably. Yeah, we should see this default alert that says that we hacked. So let's take a look now. How can we leverage CSP header? And I bit not used to a white theme, so it takes some time to my eyes to adjust. So let's enable CSP. If I enable CSP, and I hope the cache is gone, let's try to put payload again. This time, alert hasn't been pop up. And browser says that, hey, you did something. What's wrong? It happens. Fine? Should be back now. Yeah, Magic Reconnect. So, in this case, browser says that you did something that is not explicitly allowed for this page. It complains that CSP header violation found, and actually XSS is not executed. Let's take a look how the header is built. So it's again the same on the picture, but kind of more real for this demo site. This is explicit allow list of different hosts that you allow. And what is interesting here is this report URI. Report URI is a way to tell browser to report you any violation on a page to the URI you specified in this directive. So I have API here, and if everything goes okay, yeah, we see that I have a report about violation I did on the site on my backend, which allows us to do different things with content security policy. You can build monitoring on top of it. You can monitor these violations and react on it because it might be a site that you've been hacked or you are in the process of being hacked. You can also change CSP header to CSP report only, which allow you to integrate content security policy into existing sites because you will be able only to see reports, but browser will not block all the violations. It just silently report to your API. You will be able to investigate it to build correct header in order to apply, for instance, for the site that been already in production. Let's back to the slides. So CSP is a bit tricky because when real life hits, you can find different issues. By default, CSP is protected from inline scripts and from eval. But in different sites, you can use inline scripts, meaning not loading from the CDN JavaScript remotely, but embed JavaScript on the page. And one of the issues, for instance, with Google Analytics third-party tools, they utilize inline scripts a lot. In case of Google, if you use Google Analytics, they use images for tracking. And of course, you will have to whitelist all the domains that Google has for tracking. It's around 20 something. And Google explicitly says in a doc that you should do it. It's a lot, but at the same time, it works. In case of inline scripts, there are two ways to overcome it. Built into CSP, there is possibility to render nonce. Nonce is a random sequence of bytes that is generated on every request and should not be guessable by hacker. So you put nonce on an inline script and put nonce into header, and in this way, inline script is allowed. It's like whitelisted for a browser. But nonce has downside that you won't be able to use caching. You won't be able to cache your content because nonce start to be guessable. Nonce will be cached as well. Another way to overcome difficulties is to build hash from inline script to put it also in the CSP header. And in this way, you can cache HTML file because hash depends on the content of the inline script. So choose what works in your case. Eval usage, another downside or tricky part of content security policy, but nowadays it's rarely issue. The only thing that I found from the experience that Google Tag Manager uses eval by default to evaluate JavaScript variables. So they have a guideline how to avoid it, and following this guideline, you probably will be safe from eval. In existing sites, it might be tricky to add CSP, but anyway, it's beneficial to add, even with all these potential tricky parts, even if you cannot build a completely safe CSP header, you probably should try to inject it, to build it, to apply it to your site. at least you can see reportings and react on those reportings if you need to. Another example of security feature is IFrame. And we tend to think badly about iframes because iframes are not convenient, especially for development. They have a lot of restrictions. But from security standpoint, those restrictions are actually good. One of the features of iframes is that by default, browsers, they do not allow iframe and parent content to reach each other if iframe is cross-origins loaded from another domain. For instance, Stripe, when renders credit card forms, they use iframe, and the hood is it loads content from stripe.com, and in this way, customer of Stripe is doesn't need to build PCI DSS compliance because everything that is entered inside the cross-origin iframe and it's not accessible to a parent window. There is still possibility to steal credit card data because if you have a breach, hacker can utilize phishing and build overlay on top of the iframe. But anyway, the data itself could not be reached by the JavaScript, for instance. Another cool feature of iframe is a sandbox attribute. Sandbox attribute allows you to explicitly specify what features of browsers are available for iframe and what not. And it's like a killer feature because if you need to render dangerous content and you need to give a user to specify a little bit more than you usually do, so again, it might be risky because hackers can utilize it with malicious content. But if you use iframe for that, and let's back to a demo site again. Let's make sure that we still have XSS. Yeah, alert hello. If you utilize iframe for that, you will be controlled very gradually. And as you can see, the second line was rendered, but the alert didn't pop up. And again, browser complains because now he says that script execution was blocked. It was blocked because the content was rendered inside iframe, and iframe didn't allow the script to execute because the sandbox attribute restricts script execution. Let me show how it looks like. And it actually iframe element, just an iframe element, where you put your HTML. With iframe, things again a bit tricky because you need to iframe is inboxed, right? So styles from a parent window will not be applied to iframe by default. So you need to do a few tricks. First trick is that you should add a styles that is needed for that particular content to iframe directly. You might copy styles from a parent window programmatically or put some small CSS to a content that you are going to inject into iframe. And another trick is that iframe by default doesn't have dynamic height, so you need to recalculate height of the iframe on the rendering. It's not a very big deal, but when you do this, you will need to allow same origin iframe. So in this case, iframe is treated as same origin, but all other browser features are restricted, and you can allow them thanks to Copilot. I do not need to remember it by heart, but if you allow them, then probably things are going to be more risky for you. So if you are going to use sandbox feature, try to allow as less as possible in your case. Next, these features that I was taught you on a demo, and next cool feature that browser have is subresource integrity. It's very easy to apply. You just tell browser a hash from a content of JavaScript that you have uploaded somewhere. It works very well when you load content from third-party CDN servers. Like in this case, it's CDN.Fest.dev. It's something that imaginary. But if you use third-party CDNs or CDNs that you do not control, then it's a good idea to put this hash to be on the safe side. So if the CDN or maybe pipeline on the road to the CDN was hacked, you will be on the safe side, because if content of JavaScript is changed with malicious content, the hash that you put previously will not allow browser to execute the content, because content hash will be mismatched. Again, a quick demo, more realistic example. So if you decide to embed Swagger into your application, and if you take Swagger code from a third-party CDN, especially in case of Cloudflare, they're really cool, because their CDN, when you copy snippet for a third-party library, they put all those attributes, secure attributes, to a snippet. So they have hash pre-calculated for you. You can just take it and put on the side. And if Swagger, again, Swagger should be somewhere on this row. Yeah, it loads now. And if Swagger is modified on a CDN, yes, frontend will be broken. So customers will not receive features they want. But at the same time, they will be on the safe side, because if the change is malicious, yeah, let's hit a bit room, waiting while Webpack is building. So even the front end will be broken. Webpack doesn't want to build. Yeah, here it goes. So even the front end is broken. In this case, Swagger maybe not the major part of your application, and your customers will be on the safe side. And again, browser will complain that something is wrong, so you will be able to see what is wrong and what is going on. Next cool thing, and I often see that it's forgotten for some reason, because we used to the fact that crypto is not available in the browser, and we use different third-party libraries like crypto. During some period of time, we even fetched the whole node crypto into browser. But at the same time, browser has built-in features that allows you to work with cryptography. It's a crypto API and WebAuthn. WebAuthn utilizes under the hood crypto API. And you can use it to build different features or to harden your software from the web perspective, because cryptography allows you to build zero-knowledge architecture. It's when your server doesn't know the secrets of your customer. In standard behavior, when customer is logged into a server, we usually pass a username and password, and server compares password with password cache that is stored somewhere on the backend. But the issue is that by passing password to a server, you expose your secrets. And cryptography and zero-knowledge architecture allows you to avoid that, because if we look into example, it's an example of symmetric cryptography. You have ability to decrypt something only with a private key, and private key might stay in the browser. So it never leaves the perimeters that physical perimeters that you have here. It never passed to a server, and server knows only about public key, and word public says that it's safe to know everyone about this key. And here how the updated scheme will look like. In this scenario, you pass to a server only username. Server knows about public key, which was given to a server during registration. Then you encrypt a challenge. It's a crypto-stable sequence of bytes, usually big enough not to be guessable. You encrypt it with a public key, send it to a customer, and customer, knowing the private key, can decrypt this challenge and send it back to the server. And if server gives original challenge, then probably it's safe to assume that customer knows the password and it's safe to give a session to a customer. Disclaimer, this is very simplified example of these protocols. There are some existing protocols that handle many more possible threads in this flow, but it's a real one. It's simplified real example how can login be built with the cryptography and web crypto API. Another use cases that you can utilize with cryptography web browsing, like embedding hardware keys, biometric sensors into a website. It's not very hard enough, but it's very cool because you can just use your Touch ID or even Face ID to log in onto the site or other applications. Password managers, they by default use this because we want trust password managers that will keep your password in a free text form on the backend. Secret sharing tools, which is kind of very easy to build and without any dependencies because you can just utilize Web Crypto API. Security chats, different use cases with signatures. And I will not demo it because we're running out of time, but the thing is that building on a demo, it was like secure sharing tool, and building it took no dependencies at all. You just utilize browser's API and that's all. So, what take I want you to apply from this talk is that if we focus on something and we start to use it in a systematic way, like if we try to apply it as a systematic process, if we do threat modeling on a continuous basis, if we improve it as we usually do with different processes at work, then it's already a big step forward to be on the more safe side. Of course, what is important is to do it continuously, so you evaluate your decisions in the past as context changes, because you might gain more money, you might gain more customers, and stakes becomes more high. But again, those processes are not very heavy, even they can look like from the descriptions, they can be simplified to apply it right today. And remember that web technologies right now, thank you to TCXX committees and all those evolving browsers, they provide you a lot of features to add additional layer of protection to your sites and to be more secure. So stay safe in both our real world and cyber world. If you're interested in learning more, and that's all from me.
Right on, right on, right on. Thank you so much, man. Now, may you join me on the couch for some questions as well?
Of course.
Awesome. So we're a little bit short of time, so we have 3 questions here. Okay. All right. The first one is from Elder. If you were a hacker, what harmless but hilarious security breach would you execute on a popular website?
I don't know if you like Elon Musk or not.
All right.
But most likely I took a picture of a doggy and replaced all the posts of Elon Musk with a doggy.
All right, that's a good one, that's a good one. Okay. All right, next question is from Enzo. Do you think that AI tools like Copilot are a security risk for developers, or in general?
It's not risk by default. With AI, of course, at least at the current stage, you need to understand the suggestion it gives. And if it doesn't give a secure suggestion, you should catch it. So usually, from what I've seen, it's kind of secure enough. But it can't understand the dependencies, right? Because you can have different hosting environments. You can different complexity in your projects, like dependencies, maybe services, etc., which can complicate Copilot work to generate a secure code. But if the context is small, let's say in React, then most likely it will generate a secure code. Even if you try to use dangerously set in your HTML, it will try to push sanitization to you. what is interesting is that you can utilize ChatGPT to verify Copilot. Like if Copilot generated something, you can take it, put it into ChatGPT, ask if it's secure enough. If it says go, then it's probably good to go.
Awesome. Right on, right on, right on. Okay, last question. I know we have a lot of them, so you guys can meet him outside for these questions. The last one right now. What would you say are the uncommon, like not often used, but simple protection mechanisms that you suggest in this field?
Simple. It's hard to say and to take one actually. Like you should be strict as you can. To be strict during validation, to be strict rendering user output and input, whatever you need to render it into. But the single one, it's like do not connect to internet and probably you will be safe. That's the one example, the one advice I can take. Everything else.
Okay, okay. That's good. Thanks, man. That's a wrap on the questions. You guys bring your questions to this